In this video, we will be highlighting the differences between the VSEPR ideal structure, shown on the right, and the quantum optimized structure, shown on the left, of sulfur tetrafluoride. The sulfur molecules are shown in yellow, while the fluorine is shown in green. Right off the bat, we can see that both structures have a similar shape, but the quantum mechanical model seems to be slightly more bent. Both structures have a seesaw molecular shape. However, their geometric arrangement is trigonal bipyramidal, as there is a lone pair on the central sulfur atom that is not shown. First, let's look at bond angles. As we can see on the VSEPR model, this first bond angle is 180 degrees, but this is clearly not the same on the quantum mechanical model. Instead, we have a bond angle of 163.893 degrees. This next bond angle is 90 degrees in the ideal model, but 85.194 in the other. The third and final bond angle is 120 degrees in the VSEPR model and 106.539 in the quantum mechanical model. This occurs as a result of the lone pair repelling the bonds away from it. Ideally, this repulsion would not occur, which is why the VSEPR model has such perfect angles, but the quantum mechanical model takes the repulsion into account and shows how the bonds are forced downwards slightly. Because bond-to-bond repulsion is less than that of lone pair-to-bond repulsion, the bonds are forced closer together and away from the lone pair. Next, we will look at dipole moment. Because fluorine is more electronegative than sulfur, we know that the dipole moment will be away from the central atom and towards the fluorine molecules. We can determine its magnitude and orientation by adding the vectors of each individual fluorine. In the VSEPR model, the two fluorines that are 180 degrees from one another cancel each other out as they have the same magnitude in different directions. However, the lower two fluorines create a small vector heading down directly in between each other as shown. The magnitude of the dipole moment greatly increases in the quantum mechanical model as the upper two fluorine molecules no longer cancel each other out as they are not at 180 degrees from one another. Their vectors are also added to the vectors of the lower molecules, resulting in a much larger magnitude with the same orientation as the VSEPR model. Finally, we will discuss the energies of each structure. The VSEPR model has an SCF energy of negative 2.0870 times 10 to the 6 kilojoules per mole, while the quantum mechanical model has an SCF energy of negative 2.0871 times 10 to the 6 kilojoules per mole. While these values may seem relatively similar, it actually results in a difference of 74.72 kilojoules per mole. The reason the VSEPR model has a lower energy is because this is the ideal structure, and ideal structures are those with the lower energy level. This is not a realistic situation, however, as the repulsion created by the lone pair is not taken into account. Realistically, the quantum mechanical model is what is observed, despite having a higher level of energy.